I'm going to leave you with before you go today. So on page 9, I just want you to I show you how to graph lines on your TI-84, but you know that by now, because sometimes I start with linear inequalities. Okay, you haven't seen quadratics yet, so I kind of give you the full lesson on how to graph. So I'm going to skip this. The window, you understand how the window works, so you got to make sure if you don't have the right parameters, you're not going to see it, so you got to move the window so that you can see it. So let's go to page 10, and in particular, I want to focus on this part here. Let me just see here, it's a system, yeah. I want you to go to page 10 and just say systems. Okay, 2 or more lines. And I'm just going to walk you through how to do one of these. Okay, it's asking us to rewrite first. I will first, because it's already in the format that I like to have them in, I will find the intercepts first. So let's go find the x and the y intercept. So notice how after a while you should be pretty quick. What are you doing when you're doing this? You're finding points. Okay, we call them the x and the y intercept. So watch this. X-intercept y is equal to 0, so I just go like this. I stop writing down the y term. You got to be faster. Okay. You divide both sides by -6. X is equal to -5. So you found the point -5, 0. Do the same with your y-intercept. In this case, the x term goes, right? It's just 2y is equal to 30. Divide both sides by 2. Y is equal to 15. 0, 15. You found it. I didn't have to round in this case. It just worked out just fine. Rewrite, I will do that here. So I'll take this and rewrite it. Question, is this going to be a vertical, horizontal, or diagonal line? It has x and y, right? And they're all on one side. It's not like I have to bring stuff like an x or a y over where things are going to cancel out. It's not going to happen, right? There's x, y, and a number. It's a diagonal line. So we're going to rewrite. So we have the 2y, and the 6x comes over to the right side, and it used to be negative, now it's positive. The 30 is already on the right-hand side. So keep the sign it has. Okay. Divide both sides by 2. You end up with y. It's been a while since you were in intro, right? But when I do this, folks, I mean the 2 affects both of them. Okay? So it's 6x divided by 2, that's 3x. 30 divided by 2, that's 15. This is the rewritten. Okay? It's a diagonal. Slope is what? If I asked you for the slope, you say 3 or 3 over 1, right? It's a rise of 3, a run of 1. It's positive. So it's positive, so I'm expecting my line to go like this. Let's do the same thing with the other side. And I made it a little messier on purpose because I want you to be comfortable and not worry so much about what you see, but it's like, I can handle this, right? I can move stuff around. Does this look like the format we would like it to be in? There's that X here, there's an X there. Okay? It's messy. Okay? Clean it up. Combine terms, right? Combine terms. So what am I going to do? I'm going to bring this X over, and I'm going to bring the negative 100 over to that side. Okay? And convention has it that we first do the x's. Okay? So negative 4x is already there. What happens to this x when it comes over? It will turn negative, right? And the 5 is already on that side, so I keep it negative 5. Just take your time, but be able to do this somewhat fast, slow but fast. Right? So don't spend too much time. Know what to do, and just be methodic with it. So negative 4x and negative x is negative 5x. You've got negative 5y. And you've got the 100 on the other side. Now I have it the way I would like it to be in. If you missed it, I will just do the x and y intercept. These are points that allow us to graph this thing. So it's negative 5x is equal to 100. Divide both sides by negative 5. You end up with x is equal to negative 20, so that's negative 20, 0. On the other hand, for the y-intercept, the x term turns 0. You end up with that. Y is equal to negative 20. So it's 0, negative 20. So it's you basically have the same value for both intercepts. Here I'm going to rewrite. So I will just keep the negative 5y on the left side, and the 5x here comes over positive, right, to the other side. And the 100 is already there. Divide both sides by negative 5. Right, this gives you 1y. 5 divided by negative 5 is just negative 1. We tend to not write negative 1. We just go negative x. And 100 divided by negative 5 is negative 20. There you go. You have rewritten it. And I want to go back to the, so we did rewrite, and we found the intercepts. We didn't use technology to find the intercepts, but I want you to stick with this method. And let's do some more, let's answer these questions right here. I want you to type both of these equations into your y1 and y2. So grab, this is a bit of a review on how to use your calculator. Just clear whatever is in y1 and y2. Question, is plot 1 on in this case? No, because you're not doing a regression, okay? You're not doing a regression. In fact, linear inequalities, we're not going to do regression. So just type this in. 3x plus 15, and then y2, we're going to go negative x minus 20. Let's see if we can graph them both at the same time. Not seeing the other one. You know what? It's Monday. We got to take it easy here. Let's go to y equals and go to the second equation. Hover over the equal sign and just hit enter on the equal sign. We just want to graph one at a time right now. So let's hit graph. And there it is. I see it. Do you see it? You may not see it. So here's the window thing again. I'm going to go zoom standard. Let's all do that just to acquaint ourselves with this window thing again. We know, watch this, that's why these are important. We know that our y-intercept is 15. We go through 0, 15 up here. So you got to go back to your window, change y max to, let's say, 20. Hit graph again. And I can see everything I need to see at that point. I see the intercepts, and the graph is there. So let's answer this. This one here. Determine the y value when x is equal to 7. How would I do that? What function would I use if I had to go second trace? If you know the x value, you go second trace value, and then you let x be whatever that number is, 7. So let's do that. I'm going to go second trace value, x is equal to 7. And what is y? Y is 36. So when x is equal to 7, we're way over here at 36. We can't even see this on our graph, but we're just going to say that's what it is. The calculator is able to do that. The fifth option is determine the x value when y is equal to 15. What do we do there? y2 is taken, but we're going to say y2 is equal to 15 and go second trace intersect. What are we going to use? Are we going to use y2 in this case or not? I'm going to go to y3. I'm going to cheat here. Sorry, y3 and make that equal to 15. Go to y3, make it equal to 15. Hit graph. And then find the intersect. Second trace 5. Enter, enter, enter. And x is equal to 0, which we already knew. Okay? We knew that when y is equal to 15, x is equal to 0. We already determined that prior to this. Okay, so that's a review of that. Let's do the same thing with the other side. So this, we're going to go second trace value, comma, x is equal to 7. So what are we going to do now? We're going to go y equals. We're going to clear y3 for now. I'm going to also turn off y1 and just graph y2, right? This equation right here. So just that equal sign is turned on. Hit graph. Why am I not seeing it? I need to go in my x-min, go to your window, my x-min should be what? Negative 30 or something like that. What about my y-min? Also negative 30, right? This is going somewhere right in the negatives. So if I change my y-min and my x-min, I see the graph. Now I can do this one. Okay? Second trace 1, x is equal to 7, and y is equal to negative 27. That's a skill you need to know. Okay? And I want to know what x is equal to. Sorry, x is equal to when y is equal to 15. We let y2 is equal to 15. Second trace intersect. Will we be able to see the line y is equal to 15? Probably not. We're going to go to y3. Oh, it is right there. But do you see the intersection? You don't. So what do we have to change? If you want to see more this way, you have to change the window to, let's say, negative 50 for the x-min. Hit graph. There's the intersection. Second trace 5. Enter, enter, enter. And x is equal to negative 35 in this case. Okay? So this is just a review on how to use the calculator to still find points that we're missing. Okay, this is where everything wraps up in terms of systems. For now, we're only going to do 2 at a time. Go to 11. Again, I don't have to do this in detail because I've done this in the quadratic. Right? Determine the point of intersection of 2 or more lines. POIs, we call them. That's a new word for you, point of intersection. This walks you through, enter each line into Y1, Y2, find intersection, and so forth. I'm going to skip that. Let's find the point of intersection between the two lines we just talked about. So grab your calculator, clear Y3, turn on Y1 and Y2. Now that we have them both on the screen, we should be able to see them, see where they meet. Remember when you were using the three methods, substitution, elimination, solving systems last year, you were finding where they meet, right? Where do these lines meet? And so we're going to do that with our calculator, right? So second trace 5. And because you only have two lines, folks, you can close your eyes and just hit enter 3 times. It will find it. Because you only have two lines, you only one point where they meet. It's right there. It's not like a parabola that can curve in and there's another point there intersecting. There's only one intersection there. So we're going to go y1. I'm just going to copy that equation real quick. Is 3x plus 15. y2, we entered negative x minus 20. And then we went second, trace, intersect. And we found that it's negative 8.75, negative 11.25. That's where they meet. And then we graph them both at this, on the same grid. So this window, the scale you want to use for this is basically what your window is, what you've been using for your window. I need to make sure I get negative 20 in here. So I'm going to go 5, negative 10, negative 15, negative 20. Okay, so I'm using that, and you have to keep that scale going. You can't change that for x. Okay? So it'll be 5, 10, 15, 20. And I also need to make sure I get negative 15 down here. 5, 10, negative 15, negative 20. Try to be as equally spaced out as possible. 5, 10, 15, 20. I'm using the same scale on both. And here you just have to be careful, okay? Let's do the negative 20, the second line we solved for. Negative 20, negative 20, and then just connect those. And watch this. This is foreshadowing, okay? Label the line right away. Y is equal to negative x minus 20. On one of the ends. Don't do it in the middle because it's going to sometimes interfere with other lines. Just right at one of the ends. And what were the other coordinates? We had negative 5. Keep in mind this might be negative. Some of these lines will have decimals as your intercepts, but that's fine. The other one is at 15 here along the y and negative 5 along the x. Graph that line. I will label it down here. Y is equal to 3x plus 15. And the most important point right now is this one right here. This is negative 8.75, negative 11.25. This is what we call the POI. Okay. And here's your task, okay? Make sure you write this down because I'm preparing you for that next task here. Grab your calculator just real quick, okay? Turn it on, make sure you see the graph. I'm going to introduce a third equation here. I'm just going to make it up. Ready? We're going to y equals. I'm going to go 3 over 2x plus 1. How do you do that? Use your brackets. Bracket 3 over 2, so 3 divided by 2 in brackets. x plus 1. Because you're going to start seeing that more where the slope is actually a fraction. That's how you enter it. Okay? 3 over 2x plus 1. You ready? Hit graph. So, right? You see that black line there? It gets very messy when you have too many lines. So let's say I want you to find the intersection, listen carefully, between the red and the black line. Okay? What would you do in that case? I would say this. Let's turn off, go to y equals, turn off the blue line. Just hit enter right on the equal sign. Right, turn off the blue line. Good thing you have colored screens, okay? A couple years ago it was all black and white still. Hit graph. And then it's only going to graph the 2 lines for which you want to find the intersection. I would encourage you to do it this way. Some of you are going to get pretty good at having like 3, 4 lines and just figuring it out. But to me, even myself, I like this method more. So if you want an intersection between these two, second trace intersect, and just hit enter 3 times. And in this case, it would have been that point right there. So that's the point of intersection between these 2 lines. Okay? So let's go to 12. I set up the stage here for you to do that. This is going to be your homework to fill in this, and you have some time. Watch this. How many lines are we considering in this system? 4. I want you to rearrange them all. So you're going to write them in this format, okay, if possible. Then I want you to find the x-intercepts, the y-intercepts, and fill this in completely. I will say that this part right here is optional right now. I'm not too worried about this part right now, you filling in these 2 columns. I just want you to really focus on, can you rearrange? Can you find the intercept and the x-intercept? And I think I gave you enough space to do the math right in those boxes. I was able to do it. But hold it. This is where I'm gonna test your knowledge, because you're gonna have to change your window to make this happen. Determine the intersection between the lines y1 and y2, these 2 lines right here. So you're only going to turn on these 2 equal signs on your y equals, all right? And then you find it. You put down the coordinate. There should be a coordinate for this, where these 2 lines meet. Okay? Then I want you to find where these 2 lines meet, the first and the third, the first and the fourth, and so forth. That just worked out perfectly. All right, so make sure you're fluent with this, that you know what to do when I ask you to do it, because this is just part of what's coming down the pipe. This is just like the basics. You need to be able to do this fairly quickly to be okay with the rest. Okay. I believe all lines are diagonal in this case. There's not a single one that's gonna be one of the special cases. I will show you how to deal with the special cases later on with your calculator, especially the x is equal to line. There's a trick that I found on YouTube. Last but not least, you ready? Go to page 13. When you find all those points of intersections, I want you to graph all 4 lines on this grid. You don't have to scale anything, because I already did that for you. You just have to make sure, 1 line at a time, guys. 1 line at a time. Y1, you find the x-intercept and y-intercepts, plot those dots, connect the dots, label. Then you go to y2, intercepts, connect those dots, label, right? So all 4 should be on here, and I will post a key to it, so that you know whether or not you did that right. I have one that I did by hand and one that I used Desmos for, so I hope I find the right one. But regardless, you're gonna get that, okay? So that's gonna be your task for tomorrow, to do that, okay? To be able to work with systems. And be ready for a short AC on that. So if you have questions, contact me. And that's it for today, guys.